So here's your exam prep on algebraic expressions and equations. So I first wanted to mention to you very, very briefly that you may see a question on the exam that relates algebra to area and volume and perimeter. So I just wanted to quickly review some ideas that we discussed during the chapter. So you'll remember that we might, if we're talking about just strictly a length, right? So here would be a length. Then we might give that, call that using a variable as x, right? So if we consider that same length x to be true on our square here, provided that it is a square, then I can also call this side as well x. So that I would say that its area, the area of this square, would be x times x, or in other words, x squared, right? That's so, for instance, if this whole length here were, for instance, a meter, then it makes sense that, perimeter would be measured in units of, say, meters or centimeters. Whereas if I'm talking about area, then this would be x meters times x meters, so that would give me squared units, so meters squared. So that's why area has squared units. So let's look at the volume and kind of follow along the same lines. I would have my length times my width times my height here, if I'm talking about a perfect cube. So my volume here would be x, or x cubed, which is why for volume we use cubic units. So that's just a little overview relating algebra to measurement. So next in our algebra unit, we talked about combining like terms. So what does it mean for terms to be like terms? It means they have the same variable and the same exponent. So for example, if I have 2 x's and 7 x's, then in total I have 9 x's. And I can do that operation because A, they're both x's that I'm adding together, and also they have the same exponent here. Let me look at some counter examples. So if I had 2 x's and 7 y's, then I could not add them together. It's like saying 2 apples and 7 oranges, right? I can't simplify that, so I would simply write the expression the same as it started with. There's nothing to combine there. Also, here I have an x, and this is a very common mistake. Students think that they can add x's and x squareds together, but they can't, right? Because remember, x represents the length, whereas x squared represents an area, right? So I can't add those together, just like I can't add centimeters with centimeters squared. It can't simplify, so it looks exactly the same as it did at the beginning. So before we move on, I want to remind you about integers, because students often get mixed up when dealing with integers here. So remember, if I'm asked to simplify an expression, in this case, I have some variable terms and I also have some constant terms. So I can't add x's with non-x's. So I need to be able to highlight which of these can be actually added together or simplified and which cannot, right? So I can add the plus 5 with the minus 1, but I can't add x's and non-x's together. So when I combine these, then I have to take integers into consideration as well. So here I have 2x take away 7x, right? So 2 take away 7 leaves me below 0 in the number line. And if you check that on your calculator, that won't give me 5, it'll give me -5. But there's still x's. Okay? Then I have 5 take away 1, and that of course gives me +4, so I'm going to write that as +4. So a couple reminders. Let's say I have, I'm subtracting a negative. When I subtract a negative, that actually means adding a positive. So that's one thing I want you to remember for sure when you're writing your exam, and also when you're working through your CCT. So also, a point of confusion for many students is comes to the difference between multiplying and adding polynomials. So let me just highlight that really briefly for you. So let's say I have an x plus an x, right? That's like saying 1 apple plus another apple. Well, I have 2 apples, right? That's what happens when I add polynomials. However, if I were to say 1x times another x, that's like area, really. It's like I'm saying, well, I have an x times another x here, and that will really just give me x squared. So notice the difference here. One, when I'm multiplying, I'm getting like an area, and the other one, I'm just getting a length. So x times x squared, that will give me x cubed. Okay, so now sometimes these polynomials might have coefficients, right? So I need to multiply the coefficients with the coefficients. So 2 times 3 gives me 6. And then x times x gives me x squared. Hopefully this is seeming familiar. If not, maybe you need to come in at lunch and do some extra practice with me. So same here. I'm going to say negative 4 times negative 5. Well, a negative times a negative gives me a positive value, and 4 times 5 gives me 20. Okay. X times x squared, that's going to give me x cubed. And I'm done. Now, sometimes you'll see questions where I have a value outside of the bracket and a polynomial or a binomial in this case inside the bracket. What that means is that I need to remember that the value outside of the brackets gets distributed or applied to both parts inside the bracket, and it's the second one here that people often forget about. So 2 times 3x, 2 times 3 is 6, so 2 times 3x gives me 6x. 2 times negative 1 gives me negative 2. So that's, this last part, that's the part that students tend to forget about. So don't forget to distribute whatever's outside the brackets to both parts inside the bracket. So now I want to quickly remind you about the difference between an expression and an equation. So an expression does not have an equal sign. So for instance, 2x plus 3x is not an equation. I can simplify that, but I can't solve for x because there's no equal something else there. So all I can do is simply simplify by writing, 2x plus 3x gives me 5x. Right? That's all I can do with that. I can't figure out what x is because there's not enough information given to me in this question. However, if I know that if I see something like 2x equals 5, then that's something I can solve because I see what's on the other side of the equation there, and I can figure out what the value of x is because they give me enough information. So in short form, in an expression there won't be an equal sign given to you with something on the other side of it. It'll just, but in an equation there will be. So in this case, remember, when I'm solving equations, I always want to try to undo an operation by performing the opposite operation. And all of that's done with the idea that I'm going to get the variable all by itself on one side of the equation. So in this case, I can see that x, I'm subtracting 5 from x. And so in order to undo that, I have to add it, do the opposite operation. So I'm going to move it to the other side and change the sign. So that gives me x is equal to, and remember the negative 3 was there first, and then now I'm going to change the sign to plus 5. Okay, so negative 3 plus 5 will give me positive 2. And so now I know that the value of x is 2. And I can always go back and substitute in that value that I started with and make sure that the left side is equal to the right side. So for example, if I were to go ahead and plug this x equals 2 back in here, I would end up with 2 take away 5. And if I've done this correctly, then that should equal my right side, which is negative 3. Well, is 2 take away 5 equal to negative 3? Yes, it is. So that tells me that I've done this process correctly. All right, on to the next example. So in my next example, I have 2x equals negative 18. So whenever I have a variable and a number beside it, that implies that I'm multiplying. So the opposite operation to multiplying is dividing. So I'm going to divide. I'm going to divide the 2 out to get rid of it. But whatever I do to one side of my equation, I need to do to the other side. So 2 divided by 2 gives me 1. So I've really just sort of gotten rid of that. And so now I can find out the value of my x by saying negative 18 divided by 2. And that is equal to negative 9. Of course, remembering that a negative divided by positive gives me a negative value. Okay, so in the same way, I can look at this next example and say, well, I want to get my x all by itself, and so that means I need to get rid of this divided by 2 business. So I'm going to multiply by 2. And whatever I do to one side, I do to the other side. And so now that allows me to cancel out my 2 and my 2. And so 5 times 2 gives me a value of 10 for my variable. So x in, oopsies, so x in this case is equal to 10. All right, so now I'm ready for some two-step equations. So the two-step equations involve, again, just getting that x value, my variable, all by itself on one side to figure out what what the value of it is. So my coaching before, I've said, move what is furthest away from the variable first. Of course, I mean whatever's on the same side of the equation as the variable, but farthest from it. So to me, when I look at this, I think about dealing with the minus 5 first, right? So this right here. So I want to deal with that first. So how do I deal with it? Well, I try to undo the operation. So because I'm subtracting 5 on this side, I'm going to add it on the other side. And so that will leave me with simply 2x being equal to 11, and now it's plus 5. And so that leaves me with 2x being equal to 16. But I'm not done yet because I don't have my value of x all by itself on one side. I still need to get rid of this 2. So I'm going to undo the multiplying by 2 by dividing by 2, dividing it out. And then whatever I do to one side, I do to the other side of my equation. And that leaves me with the value of x, canceling these out. So x is equal to 8. So the next little bit is solving problems involving equations. So you're going to want to use the equation that's given and substitute known values into the equation. Then you're going to solve for that unknown. Let's go through an example to help you be reminded of this. Luckily, we've been doing stuff that's a lot like this, so hopefully you won't find it too bad to remember. All right, so in this question it says the total cost of a pizza, C, is given by the equation C equals 2n plus 5, where n represents the number of toppings. So strategies that I think are really important here to use are to highlight what's given. So C in this case is the cost of the pizza, right? Super important to know. And n is the number of toppings. So if it also helps you, it may be a good idea for you to go ahead and to actually write those in right on where the equation is so you don't forget. So like here, for instance, is my cost. And then, well, what is n? N is the number of toppings, right? So number of toppings. Whatever works for you. And so on and so forth. Right? So then, I'm going to go back, let's go back to my question. So the question says, well, use the equation to determine the number of toppings of a pizza that has a cost of $17. So when I look at that, I go ahead and I write out, well, what does that mean for my equation? That means that the value of C is 17, and that's what I want to substitute in to my formula wherever I see the C. So I'm going to do that. So now I know that my cost is equal to 2n plus 5. And I can't change that equation. That just relates the cost to the number of toppings. But I do know what the value of C is. We said it was 17. So I'm going to actually just put that in. And now my job is to figure out the number of toppings. Now some of you may use a different strategy. You may not want to use the equation, and that's fine. I would say if you don't know how to use the equation, at the end of the day, Use logic, use your own strategy. That is more important than using the equation. However, know that if they're asking you to use the equation, that, they're probably going to want to see that in some way. All right, so when I look at this, again, I just want to solve for n. So I'm going to use strategies that I know from algebra to solve. I'm going to move this plus 5 to the other side of my equation and subtract it. And so that's going to give me 17 take away 5. And that will leave me with 2n on the other side of my equation. So now I'm going to clean that up. 17 take away 5 is 12. So 12 is equal to 2n. So now to isolate my n, to get it all by itself on one side, I need to undo the multiplication, the divided. So I'm going to divide by 2. Whatever I do to one side, I do to the other. And that allows me to cancel out my 2's. And that tells me that the value of n is 6 in this case. So that means, what does that mean? That means, therefore, that they needed 6 toppings. The number of toppings were 6. And so that makes sense, right? If it's, 6 times 2 plus 5 does give me $17 in this case. So there are some separate examples of EQAO questions and their take up on a separate video. You're welcome to watch them if you need practice. Otherwise, you're free to start your CCT. And good luck.